brave soul with a calculator wants to help, but otherwise I'm gonna.
Do you want it as like a decimal?
Yeah.
Good. Yeah, that's right.
0.75.
0.75 is
0.75 around it.
give or take. Because we don't want to miss. This is dinner, right?
Give or take, it's exactly that.
No, because if it was really 4/3, it would be 1.333333.
Yeah, but
I just meant both top and bottom is 3.
Yay enough?
Yeah.
Let's let Nemo be H high. I don't know how to describe that. And let's let D be to the top of Nemo. Does that horrible drawing make sense?
Okay.
You're happy with this? Shame on you all. That's a beloved Disney character. Not beloved? I don't know. These are all past my time. My niece and nephew loved Nemo. Then we could say that this is Q top, right? What would Q bottom wind up being then?
It would be the same thing, only it would be plus H.
Yeah.
No.
Hooray. And so if we look at the Q top minus Q bottom, what do we get?
Quantity 0.202? No.
So if we were actually trying to, let's see, something like, the good news is that the actual Nemo is going to be a little meatier than the image Nemo. And they all lived happily ever after, except for Nemo, obviously. I did an example like that for you.
So just trying to understand what that means. H prime is the distance.
H prime is how tall the image appears. H is how tall the object is. Yay? Okay.
So the fish looks smaller than the real fish, right?
Yeah, it does seems a little compacted along the axis normal to the surface.
Oh, okay.
We're all right? Okay. Do you want to see one more example before I move on to another topic? Or are you good with this?
Yes, please.
Okay.
Can you do one example, like N1 is outside and N2 is inside, kind of like that? So what case, like if N1 is 1 and 2 is 1.33? You can just make up a story.
Well, so we could talk about what the fish sees for, I don't know, a bird overhead. But there, all you're gonna wind up doing is interchanging which one is N1 and which one is N2.
Oh, okay.
So it'll wind up being very, very, very similar, except that those two roles will reverse.
So a fish see a bird flying in the sky.
Yeah, or maybe it's hovering.
Hovering, okay.
Just, it's a seagull. It's about to eat Nemo.
Maybe the fish.
Nemo's frozen with terror.
Oh, okay.
Story writes itself. Okay, let me do one with a curved surface since I did the flat surface one, but although I did do this one for you, but I think I took this from an older version of your textbook. That's meant to be, I can cut it. Maybe I can't do better than that. Yeah, sadly no. We have some clear plastic dome that we are using to display our prize bug collection.
Taxidermy.
Is it taxidermy when it's bugs?
Yeah.
Oh, okay, taxidermy of a bug. Try to learn one new thing every day, and that's going to be the thing I learned today.
Yay.
Ladybug.
Ladybug. Every year I buy a bunch of ladybugs and I set them free in my yard to eat aphids. They're actually pretty good at controlling other insects.
Do they stay?
Not long, but I mean, you get a few days of them. If there's stuff for them to eat, they absolutely will hang out. But once they've eaten all the other insects, they go into someone else's yard. Let's see, I want the radius of curvature to be about 3 centimeters. The ladybug sits kind of centered on this thing, but 2 centimeters from a surface. You go to a garden store, you can buy like a tub of ladybugs. They're typically in a refrigerator, so that they go to sleep. But dump them out in your plants. And they'll go to town on whatever insects are there. I want n to be 1.5 here. I want n to be 1 here. And once again, we are creepily staring straight down onto this thing. Time for us to get a new hobby. We want to know where is the image of this thing. So somewhere over there, off screen, I suppose. We still have n1 over p plus n2 over q is n2 minus n1 over r. Are you guys mocking my...
No, we were asking what 3 is.
I do the best I can. Yay?
Yeah.
All right. If I'd known I was going to be a teacher when I grew up, I probably would have spent more time learning how to write, right? Let this be a warning, it could happen to you too. I mean, obviously with my personality, no one ever thought I was going to wind up, you know, in a job where I interacted with people. So, yeah, here I am. What is N1 here?
1.5.
Excellent. What is P? 2 centimeters?
How can you move so fast? And one is 1.5.
What's N2?
Object is inside a medium
1.
where n is 1.5.
Oh, okay.
Q is what we're trying to solve for.
The type P was from wherever you're watching, but it's from the actual object to whatever.
It's from the object to the surface.
Index of refraction. I mean the.
Yeah. So coming back to this horrible drawing, remember that P is the distance from the object to the boundary between the two media.
Everything.
So that way you mean boundaries or you mean like?
I mean the surface.
Oh, the surface.
Apologies.
Like the edge of something, right?
Yeah, specifically the surface between where the two indices of refraction change from one to the other.
Oh, okay, good, okay.
Pardon. And then we've already said this, that N2 is 1, and 1 is 1.5. R here is what? Plus or minus?
What?
Positive
I
three.
have minus
minus.
also?
Why minus?
Because it's
Where is the center of curvature?
It's
Oh, it's not.
It's on the front side.
Yeah.
Yay? And so we have minus half over 3 is like 1 over 6, I think. Did I get that right?
Yes.
So then 1 over q is equal to 1 over 6 centimeters minus bad mark. Minus 1.5 over 2 centimeters, which is the same as 1 over 6 centimeters, minus multiply top divided by 3 is minus 4.5 over 6 centimeters. Is that also true? So minus 3.5 over 6 centimeters. So Q is the inverse of this, is
Negative 0.583. Sorry, that's,
it's got to be greater than 1.
I know, sorry.
No. 12 over 7 is 1 and
Don't do this.
1 and 5/7. So 5/7.
I get 1.714.
1.5 something?
1.7.
14.
And so what does that say about our little ladybug friend?
Is closer than we think it is.
This is just making a mockery of a proud insect. Image object, yeah? So the object is actually 2 centimeters under the surface, but the image is apparently only 1.7 centimeters under the surface. Yay? Questions, comments, concerns?
Does that mean the image is virtual?
This image is in fact virtual. Yay. Okay. Let's look at, well, I'm going to say let's look at thin lenses, but it's a long walk from where we are to actually get to the thin lens equation that I've already started using, and you guys have too in labs. So settle in, get comfy, got about 19 minutes. Oh my goodness. Professor Liu wants to talk to you guys about the speed of light.
I should need this equation right there.
I think he was giving an exam in here this morning.
Are we studying, next week, are we doing still optics?
I think I'm closing it out, and then I'll start transitioning to the theory of the special theory of relativity.
Because we have an exam on Thursday, that means we
We
have
do.
to finish the whole thing before that.
Yes.
Next Thursday. And that's your next week.
We're closer than you actually think to being done with.
I need to look at my Google calendar.
Twelve-ish pages of my notes. So, okay. So, I'm gonna keep our friends close. I'm gonna keep that nearby. So, we want to start moving towards thin lenses. So, for a thin lens, you have refraction at 2 surfaces, or for lenses in general. So the image produced by refraction at the first surface serves as the object for refraction at the second surface. So Hooray. So let's badly draw this. I'm gonna, I guess, badly draw this in 2 steps. I don't know if I'm gonna be able to draw this well. I should have photocopied this for you. So this is not a thin lens. This is not, or at least not necessarily. What we're going to do is first we're going to address this for a potentially thick lens, and then we're going to insist that the thickness of this thing collapses so we can treat it as thin. So we'll take our general answer and apply it in a special case of the front surface and the back surface are actually pretty close together. Does that make sense? What our plan of attack is? So something like that. There's our object. So would you kind of agree that this is the center for this front face? It's not too big a one. And so just aim that thusly. It's not fair. I want to aim it. That looks too much like it's going to go through the center. That doesn't look like it'll go through the center, right? Okay.
No.
So, happy enough? Then we could also look at, so this, I don't know. That looks like it'll do something like that. Is that reasonable-ish? Okay. Then I also want to draw a ray that goes straight towards the center. Oh, actually, that's not what I want to do. It's not, well, that ray would work, but it's harder to draw. Let's draw one that really does seem to want to go straight. Why is drawing one that wants to go straight towards the center nice?
Doesn't matter.
It won't refract, right?
Mm-hmm.
Does that make sense? So then,
Wouldn't it refract on the other side?
yeah, so maybe I should dot that. So then, I'm going to so we are just looking at the front surface, right? And so do you see that the image from the front surface is going to be back here? So this is I1. Does that make sense? So okay.
Is it possible to extend the rays to the other side and also have an image? Or how do we know that the image will be on the left side?
So if I were to continue this, right? This one is going to come out, since it came in parallel,
Go through the axe?
it
the
wants to
focal
come
point.
out way out here, right? And so this ray is already under it, so they're actually spreading apart. They're getting further away. Does that make sense?
Yes, thanks.
So they're intersecting on this side. So there is the thickness of our lens. If I wanted to carry this forward, I would say that I2 serves as the object, so, sorry, I1 serves as object 2. And so P2 is from the back side to where I1 is. Better, worse, same?
Makes sense.
Okay. Then I'm going to put this aside for a moment, and then I'm going to do another case where this is more, I think, what Lorenzo is asking. I'm going to fail this again. Well, that's not terrible. So again, I'm going to give us an object. Did I label this one? I did. Still want this to be T. This is going to be P1. Then I can just take this. Work at all. pretty awful, but it'll have to do. And then I need to extend that. Guess we're gonna be sad. Oh, wow. I should have curved the lens more. Many, many, many different. Okay, that's at least sort of passable. With this one, I'm just gonna accept that I can't draw. Oh, come on. Or, that is some kind of wiggly line. We're going to pretend that these two want to meet here. So there's our image. That makes this Q1, and it makes this P2. Is that kind of okay? So R1, R2, R1, R2.
So if we say that P is for object and Q is for the image, are we saying that that point over there can be either image and object at the same time?
So I subscripted for which surface we're talking about.
From
So
my question is on that side, the one that you mark it with P2 and Q1.
yes. So the image for the first surface is the object for the second surface.
Okay.
And so Q1, but P2.
Thank you.
So welcome, sir.
Oh, hi, everybody. I'll sit over here.
I was
So then, and we won't get all the way through this. We have our equation, n1 over p plus n2 over q is n2 minus n1 over r. For our first pass through this, let's assume that there's air on either side of the lens. And so in that case, what is n1?
1?
1. Yeah? So we can say that 1 over P1 plus n over both of these n. N over Q1 is equal to n minus 1 over r. Yay. And I guess I should, because I right now assume that R1 and R2 could be different, should subscript the R also. So I'm out of time. All right. As always, you guys are awesome. Have wonderful days. Thank you for stopping by. Don't be strangers. Enjoy your days, but not so much so we don't see you tomorrow for A fun-filled lab.
Yay!